Hi, everyone. Moving on today with the third lesson of our fourth unit here. This lesson is on rational exponents, and all that is meant by the term rational is that it means fractional exponents. So basically, when your exponent is a fraction, like you can see here, 5 to the power of 1/2, right? The exponent's a fraction. That's what we're going to be dealing with today, and how to evaluate when we have rational exponents. So before I start with the examples, just looking up here, it's just showing us basically how we could write a fractional exponent as a root if we wanted to. So here we see 5 to the power of 1/2 times 5 to the power of 1/2. That is the same thing, or also could be written as the square root of 5 times the square root of 5. Same thing over here, 4 to the power of 1/3, 4 to the power of 1/3, 4 to the power of 1/3 is the same as writing the third root of 4 times the third root of 4 times the third root of 4. Okay, and I'm going to go into more detail as to how we get from this over here to writing it as a root, and then going the other way if you're given a question like this and are asked to write it as a power, then how to go from this formation into this notation here. Okay, so the other part here, just to remember, quick recap, when we are multiplying with the same base like we are here, remember, you add the exponent. So what we're doing is taking the power of a half, adding them. Half plus a half is 1. Okay, same thing here. A third plus a third plus a third, you see right there, is 1. So it's the same thing as 4 to the power of 1. Okay, so just a quick recap there on that. So how do we deal with fractional exponents? Actually, I'll just leave this like that because I wanted to concentrate on what's in this black box here. So when we have a fraction as our exponent, basically what happens is the numerator of that fraction stays as the exponent. The denominator becomes the root. Okay, so in this case, we have b to the power of x over y. So the x stays as the exponent, and then the y, which is the denominator, becomes the root. Okay. To show you with actual numbers, which might make more sense, what do we mean by that? So let's look at example 1a here. We have 5 to the 1/3. So as I had said up here, the numerator in your fractional exponent stays as the exponent. The denominator becomes your root. So in this case, the numerator is 1, so the power of 1 stays, and then the denominator is 3, so it becomes the third root of 5. Okay. If you had to evaluate that, you would have to punch into your calculator the third root of 5, and for most calculators, that'll be a second function key to find the third root, or the fourth root, or the seventh root, or whatever number. Usually, it's the second function key will have a square root sign and a little x here where the 3 is. Okay, so this one doesn't say to evaluate, it just says rewrite each expression in radical form. So radical form means root form, so the third root of 5. Okay, looking at b, we have 6 to the power of 2 over 3. So just like I said up here, with our rule, the 2 stays as the exponent, and the 3, which is the denominator, becomes the root. So 6 to the power of 2 over 3 is the same thing as the third root of 6 squared. Okay. It doesn't matter what order you do the operation in. So if you're asked to evaluate this, you could do the third root of 6 and then square it, or you could do 6 squared and then take the third root of that. Okay. Sometimes you'll notice it'll be easier to do one or the other because you'll get you won't be dealing with decimals. So if you were asked for the third root of 8, that's exactly 2. Okay, so if you were asked for the square root of 16, that's exactly 4. So anytime you have exact numbers, do that operation first. So usually you'll square root or whatever the root is, third root, fifth root, first, and then do the exponent. For the most part, it'll work better that way. But like I said, either way, either order is fine. Okay. And then the last kind of one I wanted to go over here is if we have a negative exponent. So let's look at C, for example. Remember, when we have a negative exponent, we can't deal with negative exponents in terms of evaluating. So in order to evaluate a negative exponent, we've got to change it to a positive exponent. So remembering back to last lesson, how do we do that? we simply, when we have a negative exponent like we do here, 8 to the power of negative 1 over 4, we flip the base, so the 8 becomes 1 over 8, and then the exponent becomes positive to the power of 1 over 4. Okay, now we can take this here and express it as a radical. So we know from today's rule that 1 in the numerator stays as the exponent, the 4 becomes the root. So this then can be written as 1 over the 4th root of 8. Okay, same thing here. We have a negative exponent, so flip the base. 26 becomes 1 over 26 to the power of now positive 3 over 4. The 3 stays in the exponent, like we see right there. And then this 4, which is the denominator of your exponent, becomes the root. So this can be rewritten as 1 over the 4th root of 26 cubed. Okay, so all of the other questions you see here, E, F, G, and H, are done the exact same way. Okay, so take a look at them. Make sure that you understand what's going on. And obviously, if you have any questions, then feel free to ask me. But like I said, these all here, E, F, G, H, are done the exact same way I did these ones. So just remember, if you have a negative exponent, to flip the base, and then you can evaluate that. If you have a positive exponent, then obviously no need to flip anything. Okay. Number 2 is asking us to rewrite each expression in exponent form. So now we're doing the opposite of what we just did. In number 1, we were given the expression in exponent form, and we wrote it in radical form. Now we have it in radical form, and we just want to write it in exponent form. So just do the opposite of what we just did. So if we have the 3rd root of 7, to write that in exponent form, we know whatever the root is has to be the denominator in our exponent. So if it's the 3rd root, the denominator has to be 3. And the 1 here is implied, the power of 1, so we just keep 1 in the numerator there. If you are given a question where it shows you something like this, the square root of 10, and there's no number written here, like let's say that 2 wasn't there, that's what we're saying, it's implied. So if you see the root of any number without a number written there, it's automatically assumed to be a 2. So the square root. Okay, so if this is saying the square root of 10, again, this 2 has to be the denominator in our exponent. So the 2 goes there. And then also the 1 is also implied, 10 to the power of 1. So that 1 is your numerator, 2 is in the denominator. Okay, so let's just deal with 1 or 2 here where we have where we're dealing with not a power of 1, like this is power of 1, and A was power of 1. C is to the power of 2, and we have the 3rd root. Okay, so I would probably go straight from here right to the final answer. If you want to do the step in between, you can, but it might, to me, even be a bit more confusing. We know we have the power of 2. That power of 2 is going to remain power of 2. We don't move that. We don't change that. The only thing we have to add into the exponent is the denominator. And we know because this is the 3rd root, the denominator in our exponent becomes 3. So the 3rd root of 25 squared can be rewritten as 25 to the power of 2 over 3. So whatever your exponent is in the original expression, that stays the same. Okay. What you need to do to change it into exponent form is take whatever the root is and make that your denominator in the exponent. Okay. So same idea over here. Again, I probably wouldn't do this step. I would just go straight from this original form of the expression into this exponent form here. So again, we have power of 2. We still have power of 2. We have the 3rd root of 14, and then that 3 becomes the denominator. If you were asked to express it with the base not being a fraction, like let's say the question said you can only express it as an integer or a whole number or something like that, so we don't want 1 of 14, we don't want a fraction, we can change this into a non-fraction by saying 14 to the power of negative 2 over 3. So it works the same way. If you have a positive exponent in the denominator and you want to get rid of that denominator, you do the same thing. You flip the base and change the sign on the exponent. So we flip 1 over 14 into 14, and then the sign on the exponent, instead of being how it's positive here, becomes negative. Okay. Moving on to the rest. So they're all done, again, very similar, pretty much the exact same way. We have the 4th root of 12, so we know the 4 needs to go in the denominator there. We have remember the 2 here is implied, so the square root of 10 to the power of 3. 3 is the exponent, so 3 stays right there in the numerator. Because it's the square root, the 2 goes into the denominator. Okay, so same thing for all of these questions like we've done. So take a look at them again and let me know if there's any questions at all. Okay. The last one here is saying evaluate each of the following without using your calculator. So it's basically looking to see, do we know what the exponent rule with rational exponents, how to apply that? So we don't want you to putting in 25 to the half into your calculator. You need to know that 25 to the half is the same thing as the square root of 25, right? Because the 2 is in the denominator, the 2 becomes the root, so the square root of 25. Then if you need to put that into your calculator, I guess go ahead, but hopefully most of us will know that that's 5. Okay. Here, 3 is in the denominator, the 1's in the numerator. So the 1, it stays 8 to the power of 1. The 3 becomes the third root of 8. Third root of 8 is 2. Over here, so here's, like I was saying before, it doesn't matter what order you do your, whether you do the power, apply the power first or apply the root first. But in this case here, we have to the power of 3 over 4. So the 4 becomes the 4th root, and the 3 stays as the power of 3. Now, if I were to do 16 to the power of 3 first, that'd get pretty tough without a calculator. So what I would do here, in this case, you do the 4th root of 16, which gives us a nice number. There's no decimals here or anything like that. It gives us a value of 2. And then 2 to the power of 3 is a lot easier to evaluate, which will give us 8. Okay. Same idea here. The 3 means third root, and the 2 here in the numerator stays as power of 2. So if we did, we could do 8 squared is 64 and then get the third root of that, which is 4, but it's probably a little bit tougher. If we do the third root of 8, that's 2, and then 2 squared, a lot easier, right, to do 2 squared without a calculator to get us 4. I'm not going to go over all the examples here because they're all done in the same way. But let me just pick one here with a negative exponent. So let's say something like e. So remember, only difference here now before we start evaluating anything, because we have a negative exponent, we need to flip the base. So the 25 becomes 1 over 25, and then the negative 3 over 2, once we flip the base, we can write that as positive 3 over 2. And now we do what we've been doing in all the other questions. The 2 here means square root of 25, and the 3 means power of 3. So the square root of 25 is 5. Then 5 cubed gives us 125, so our final answer is 1 over 125. Same thing, so like I said, pretty much the same way to answer all of them. Something like, I guess G is a bit of a trick, because the negative 16 is in brackets, and it's asking us to get, so to the power of 1/2, again, that 2 would come down there and means the square root of negative 16. And we know we can't take the square root of a negative number, so there's no answer for that one. Okay. We could do here the third root of negative 8 we can do, right? The third root of negative 8, sorry, is negative 2. So that works fine. But we can't do the square root or any even root of a negative number. Okay. Last thing to point out here, if you see or look at, look at G and H, you can see the negative 16 is in brackets, the negative 8 is in brackets, so the exponent applies to the entire negative 16 and the entire negative 8. Here, the base is not in brackets, like the negative is not part of the bracket, so this exponent only applies to the 27, not to negative 27. So we rewrite it like this with a negative outside, and then you do just positive 27 to the negative 2 over 3. Flip the base, becomes 1 over 27 to the positive 2 over 3. And the negative just stays on the outside there, stays on the outside there. So this becomes the third root of 27, which is 3. And then 3 squared, which is 9. And then the negative just follows along all the way down. So your final answer is negative 1 over 9. Okay, so just be careful. If the negative is in the bracket, like it was in these questions, then the exponent applies to the entire negative 8 and the negative 16. If the negative is not in a bracket, then the negative stays outside. Okay, so good luck with that. And again, let me know if there's any questions. Thanks.